In this example, it looks like we have the integral of this function here, 4 plus the square root of x, being divided by 4 minus the square root of x. And of course that is with respect to x. So if you'd like, go ahead and pause the video, give it a try, and come on back and we'll work it out together. Okay, so looking at this, it seems like it's going to be a candidate for a U-substitution. And let's go ahead and make this entire denominator our u. So we could say u is 4 minus the square root of x. Okay, so a few things will happen here. Let's go ahead first and differentiate both sides. So du equals, and then the derivative of this 4 is just a constant, so it goes away, it goes to 0. So then we have minus, and then we have 1 over 2 times the square root of x dx. Okay, so if we're going to solve for dx now, dx is going to be, we'll multiply both sides by negative 2 square roots of x. So negative 2 square roots of x du. Okay, and that will be what dx equals. And let's go ahead and see what we have here when we make these substitutions. So we have the integral, and we have 4 plus the square root of x over my u, and then this dx then becomes negative 2 times the square root of x du. Okay, well, sure I have a u here and a du here, but I still have square roots of x kind of around. So what I'm going to do is, right back here, I'm going to go ahead and solve for this square root of x so I can force everything to be in terms of u. Okay, so if I do that, on the right side it's a negative square root of x, so if I go ahead and move this to the left and then subtract the u, I'll have the square root of x equals 4 minus u. Okay, and that's going to be a great candidate here for a back substitution. We'll go ahead and put this back in for the square roots of x. So let's go ahead and rewrite this now. So we have the integral of, so we have 4 plus, and then the square root of x was 4 minus u. And we're going to multiply that by negative 2 times that 4 minus u du all over u. Okay, well that might look not very nice, but it should simplify pretty nicely actually. So let's go ahead and look at just this first set of parentheses. We have 4 plus 4 minus u, so that'll just be an 8 minus u. And then here if we were to distribute this, we would have a negative 8 plus 2u, or we could say 2u minus 8, and all that's over u, du. Okay, so already that's a little bit better. Let's go ahead and multiply that numerator out and see if we can kind of deal with this denominator of u. So it looks like 16u minus 64 minus 2u squared plus 8u all over u du. And we'll keep shuffling up here. So let's put this everything in standard form. So we have a negative 2u squared. We have 16u and an 8u, and that'll make a 24u minus 64 all over u du. And let's go ahead and then divide each of these three terms and give it this common denominator of u and simplify. So I now have the integral of negative 2u plus 24 minus 64 over u du. And now this is not too bad at all. Okay, so we have three pieces to integrate. This negative 2u, this positive 24, and this negative 64 over u. So each of these is going to be pretty easy in and of itself here. So we have negative 2u. So the integral of 2u is going to be u squared, so it'll be negative u squared. The integral of just this constant 24 will be 24u. And then the integral of 64 over u, so that'll be a negative 64 times the natural log of the absolute value of u. And then, of course, our plus c at the end. Well, we've got u in a couple of different places, so let's go ahead and plug that u back in. So if we go back to the top, we saw that our u was 4 minus the square root of x. So let's go ahead and make that substitution. So negative 4 minus the square root of x squared plus 24 times 4 minus the square root of x minus 64 times the natural log of 4 minus the absolute value of x plus c. If you would like to at this point, we could multiply everything out and simplify it a bit more, or if you just think, well, that seems good enough to me, that's okay too. But I know by multiplying this guy out and looking at him, I'm going to have some like terms. So let's go ahead and clean it up a little bit. So it's negative here, and then we'll go ahead and square this. So 4 squared is the 16 minus twice the product of the two terms, so 8 square roots of x plus 96 minus 24 square roots of x, and then of course just minus this last term here. So putting this negative through here gives me a negative 16 plus 8 radical x minus x plus 96 minus 24 square roots of x, and then minus the rest, of course. That will be left unchanged. So now let's look to see what kind of commonalities we have here. It looks like, and we're just looking at these, 1, 2, 3, 4, 5 terms. It looks like we have our plus c over here, so any constant that we have over here can kind of be consumed by the c. So this minus 16 and plus 96 I can kind of ignore because I have this plus c. So I have 8 times the square root of x and negative 24 times the square root of x. So that's going to be negative 16 square roots of x. And then this minus x could be out front there, so minus x. And then minus 64 times the natural log of the absolute value of our 4 minus the square root of x plus c. Okay, so that's cleaned up a bit, and that looks not too bad at all. So here's the expression then that will be the integral for, and let's go all the way back up to the top, the integral of 4 plus the square root of x over 4 minus the square root of x with respect to x. And let's just go ahead and look at that one more time. There we go.